This is our last video from chapter 11, and we are covering 11.3. And like most of the videos from these newer sections, I'm breaking them up into more than one. So if you have your textbook, I believe I'm going to go up to page, what is this here? This page, the second page, 730, and I'm going to stop at example 2. So don't go further than that if you're using your textbook. And the way that we're going to solve these radical equations, which is what this chapter is called, is we're going to be having to do something that gets rid of the square root. So remember, square root is pretty much breaking down a perfect square. So the opposite of taking the square root of something is actually squaring it. So you're raising it to the second power. So in its simplest form, if I wanted to get x by itself, and notice I'm taking the square root of x, to get x alone, I would show that I'm squaring both sides of the equation, or I'm raising both sides of the equation to the second power. Now by doing that, the radical gets canceled out by squaring it. So now I'm just left with an x on the left side, which is a good thing. And on the right side, you're just raising 3 to the second power, which is 9. And that's your final answer. Now always check your work in these examples to see if you did it correctly. So what you would do is you would take your answer of the square root of 9 and check, well, does the square root of 9 equal 3? Yes, so that made sense. I will be making this a little bit more difficult by adding some steps outside of the radical. So in these next few examples, if we notice in number 2, I added a -4 outside of the radical. So you always have to get rid of what's not in the radical first before you can square anything. So since -4 is outside of the radical, the opposite of -4 is to add 4 on both sides. So that cancels out. And now we're adding 4 on the right side. And we're left with the square root of y is equal to +4. How do we get the square root by itself? We are going to square both sides, or raise both sides to the second power. So y is then equal to 16. And if you want to check your work for these, I'm hoping that you're writing them down along with me. You would be plugging 16 back into this radical here. For number 3, notice we have 2 outside of the radical x, so we're multiplying the radical by 2. And then we're also subtracting 10. So just like regular inverse operations, we undo addition and subtraction first. So the opposite of -10 is +10. +10. And we are left with 2 root x is equal to 10. And then to get rid of the multiplication, the inverse of multiplying is dividing. So this says 2 times root x. So to undo that, we're going to divide by 2 on both sides. And then we're left with radical x equals 5. And then the same last step, you are going to square both sides of the equation. So we are left with x is equal to 25. And to check your work, you'd plug 25 back into this radical here. For number 4, just be mindful of what's going to happen here. I will give you a heads up. We are going to get a fraction. So I'm hoping you're remembering how to raise a fraction to an exponent, which is something we had done together. So on this side, just like number 3, we're going to undo the addition and subtraction first. So that means we have to add 2 on both sides of the equation. And we're left with 4 times root x is equal to 2. And then we are going to divide by 4 on both sides because this is saying 4 times root x. 2 divided by 4. We are keeping all of our answers in fractions in their simplest form. So then we have root x is equal to 2 over 4, which you hopefully are quickly simplifying is to 1/2. And then the last step, you're going to square both sides of the equation. And to square the fraction, we want to square the whole thing. Those are supposed to be my terribly drawn parentheses. And we are going to be left with x is equal to, you square the numerator, so 1 times 1 is still 1. You square the denominator, so 2 times 2 is 4. And again, to check your work, you plug this into the radical. Now I'm hoping some of you are questioning what happens if the equation does not equal 0. So I have one of those here for you. It's the same idea as things that we've been doing before. Hold on, let me actually erase something out of here because we haven't done that much yet and I don't want to get too far ahead. So hold on, let me just rewrite this one. Let's do 4 root x. Let's do plus 12 still. And we can still have that equal to 20. I'm just deleting some stuff out since we're not at that level yet. And so what we would do for something like this is we're still going to undo this. So notice I threw in addition now. So the opposite of addition is subtraction. So it doesn't matter that it's equal to 0. You still do the same thing. And we are going to be left with 4 times root x is equal to 16. Then we're going to divide by 4 on both sides. And we're going to have radical x is equal to 4. Not sure why I switched colors. And the last step, to square both sides. And we're going to have x is equal to 16. So whether it's equal to 0 or not, the math is still the same. Just remember that the only new inverse operation that we learned from this video is you square the square roots to get the variable inside by itself.